A cylindrical tank. A cylindrical tank of radius 7 centimeter, having height 20 centimeter, is half filled half filled with water. Find find the level of raised water raised when when a cube of side 7 centimeter immersed in it. So what we have given? We have given a cube. Let's say this is a cube of side 7. Let's say A is equal to 7. Now we have a cylinder. This cylinder having a radius 7, and it is half filled with water, having a height 20 centimeter. Now it is half filled. So up to this level it is filled. So that is 10 centimeter. It is filled to a height of 10 centimeter. Now when we are immersing this cube in the cylinder, let's say this cube is come at this position. Now the space occupied by the water in this is occupied by the cube. Now the level of the water rises because of the immersing of this cube. So the water level is come here up to this level. So this is the rise in the level of the water. Let's say the rise in the water level is denoted by H dash. Now this portion is created due to the immersing of this cube. So we can say that the volume of this portion is nothing but the volume of cube. So the volume of cube is equals to A cube. Now this volume of cube, the volume of this space is nothing but volume of the cylindrical part, that is equals to pi r square h dash. This portion is nothing but in the shape of a cylinder having radius r and the height is h dash. So these two are equal. Now equating these two equations, a cube is equals to pi r square h dash. Now we have to find h dash. So h dash is equals to a cube divided by pi r square. The value of a is 7 cube, that is 7 into 7 into 7. The value of pi is 22 upon 7. So 7 is coming on the upside. The r is 7, so 7 into 7. Now cancel all the common terms. 2 sevens are get cancelled. So we left with 49 by 22 centimeter. So the increase in the height is 49 by 22 centimeter. Now we move to the next question. Water is flowing at the rate 15 km per hour through a pipe of diameter 14 centimeter into a rectangular tank which is which is 50-meter long and 44-meter wide. Find time in which find the time in which level of water rises by 21 centimeter. So in this question we have given a pipe. Let the pipe is in the shape of a cylinder. This is the pipe through which the water is flowing. Now its diameter is given to us. So its radius is diameter divided by 2, that is 7 centimeter. Now the water is flowing through this pipe with a speed of 15 km per hour. Now the water flow through this pipe is at the rate of 15 km per hour into a rectangular tank. Let's say this is a tank, which is 50-meter long. Its length is 50 meter and it is 44 meter wide. That is breadth is 44 meter wide. Uh, Now the water is flowing through some time period. During this time period, the level of the water in this rectangular tank is rises up to 21 centimeter. So its height is 21 centimeter, or you can say 21 upon 100 meter. Now, so we have to find the time. We have to find the time for which the water is flowing, so that the level of the water in the tank is 21 centimeter. Now, first of all, the volume of water flow through pipe we have to find out. Let's say the water is flow through this pipe for the t hours, so that the height becomes 21 in this rectangular tank. Let's the time is t hours for which the water is flowing. So the volume of water flow through this pipe during t hours is defined as area of cross section into velocity into time. So much amount of water is flow through this pipe. So the area of cross section, that is the cross section of this cylindrical pipe, is nothing but a circle. Cross section is nothing but a circle. That is pi r square. That is area of cross section. So the area of cross section is pi r square into velocity into time. Now we put the values. The pi is 22 upon 7. The r is, now as r is in centimeter, now we convert all the units in meter. So 7 centimeter can be written as 7 by 100 meter. So it's square, so 7 by 100 two times. Now the velocity is given in kilometer per hours. So again we convert this kilometer into meters. So we write 15,000 meter per hour. That is velocity, and the time is already in hours. Now we write all the units in meter and in hours only. So so much, as all the units are in meter now, so much meter cubic of water flow through the pipe. So this water flow through this pipe is stored in the rectangular tank. So the volume of rectangular tank is equals to the volume of the cuboid, that is LBH, that is 50 into 44 into 21 by 100 meter cubic. So the volume of water flow through the pipe is equals to the volume of the water stored in a rectangular tank. Now we are equating these two equations. So this is first equation and this is our second equation. From equation 1 and 2 we can say that 22 by 7, 7 by 100, 7 by 100, 1500, 15,000 sorry, into T is equals to 50 into 44 into 21 by 100. Now we are cancelling all the common terms. Now first of all 100 and 100 are get cancelled. This 100 is cancelled with this 100. Now this 7 is cancelled with this 7. Now 22 is cancelled with 44 two times. Now 50 into 2 that is 100. 50 into 2 that is 100 is cancelled with these two zeros. Now 7 and 21 is get cancelled three times. So now the time is equals to 3 multiplied by 100 divided by 150. So that is equals to 300 divided by 150, that is equals to 2. So 2 hours are required. So the required time is 2 hours. 2 hours is required to fill this rectangular tank to a height of 21 centimeter. Thank you.